Primitive one is geometry is modified using modification function, but this is a parameter. Okay, for example, entrance angle, bulb area, section shape, bulb height, transform height. This kind of parameter are changed using parametric modification function. Okay, so design parameter all plus this is presumed design parameter. This can be a function of one dimension or two dimension, three dimension, depending on the view, depending on the freedom. The original geometry can be easily defined by direct selection of well-known design parameters, as I mentioned here. This is design variable according to computing time can be reduced a lot. Here is always guaranteed. That is the advantage. But still, we are handling this kind of parameter. The restriction of whole generation are limited, as I mentioned. Next. This is example. SH curve. This is a pursued function is a function of x. Okay. And the bulb transform shape, and then also section shape. And design with line. This is XYZ3 function. This is a parabolic type, and also section unit type. And then we can, introduce this kind of, catchy function, modification, add function. But this is up to you. You can generate any type of function. Actually. So now, our KCS is applied for these two methods. One is the geometry handling, the other is parametric handling by using modification function. We use, KCS. Design speed is true number is 0.26. Akimoto, he, calculated, motion using this model. Actually. So, this is okay, this is geometry. Object function is total resistance, composed of weight-making plus, form factor and friction. Friction is IPTC. Friction line is used. Design variable is 40% of LPP, 4 part. It's free. So, 40% of 4 parts. Total, 40% is, changed. Constraint, displacement 1% plus minus. Key line is fixed, and verbal profile can be changed as well. And at 12 station, the generate view hole should be better to the original one. Because we are now, optimizing, we are now optimizing without weighting. We are not changing this weighting system using potential code. Algorithm is, direct searching SQP method. So this is parametric modification. Okay, this is entrance angle. So this is parameter of design error. Instead of this design of parametric modification, bell shape modification function you can see here. Here bell shape. So this is 1, 2, 3, 4, 15 and 1, 2, 3, 4. 19 design variables are used for this bell shape modification function. So we'll compare the result now. Next please. So this is result of original and optimum, 4 parts, because after part was not changing. Original and optimum. So this is parametric modification result. You can see here optimum. This full number is 0.26, whose speed is relatively high. This large container shape. So even though speed is relatively high, design speed is high, accuracy angle is increased. You can see here. Usually accuracy angle is decreasing, but this is opposite to our expectation. Actually, same result can be seen here as well. This is bell shape. Bell shape give more freedom, as I mentioned earlier. Similar result, okay? Also, entrance angle is increased. Next please. This is comparison between two results, parametric modification. We achieve weight-making resistance around 8% reduction. Okay? And bell shape modification around 10% reduction. But we can see this is 5 hours time. This is 31 hours. Nowadays, Korea, Japan, China, the Xinjiang are very busy. They need keep at least 1 day, not more than 1 day. If we use CFD for our store, it will take a week, okay, with the same, green number, that kind of thing. But potential for so far, usually, if we are not using modification function method, for example, direct, the manipulation of geometry, it will take many days. But because of modification function is used, this is 31. But this parametric modification function method is just matter of hours, okay, 4 or 5 hours. Okay. That is one of big advantage. But result almost same. Okay, we tested model here next week. The original and the 4 part only the change next week. Similar, compared to the safety result achieved here. This is reference is big model. This the big model conducted in larger the our scale rate is large, becomes smaller. So just we compare original and Ultima. We achieve around 5% reduction. This is summary of result. Okay, this is computation result, and this is CFD model test result. You can see CR. The CW and CR is different. CR consists of 4 factors. Okay, but by experiment we cannot easy to derive to distinguish what is the way making 4 factor. But actually, this is CR is the component or the component taken out by the IPTC, the friction line, okay, from totality. So ESP around 2%. Because KCS is a well-designed shape. If we use well-designed shape, model shape is well-designed, the achievement is huge. But this is one of well-designed, one of Korean Xinjiang design. Okay. Because of that, the achievement is not so good, but this is done by student, okay, by program. But cases designed by well-experienced designer, okay, one of the best designers in the world, I think, because Hyundai design. You can see here, as I mentioned earlier, entrance angle was increased with Ultima design. You can see this Ultima, the wave peak is high. But shoulder wave in shoulder, near shoulder is decreased. Okay? Next page. You can see here. Okay, original and Ultima. Original and Ultima wave peak is increased. But wave measurement also increased. But here, the gradient is decreased. Due to this gradient, wave gradient decrease, the pressure distribution is relieved. Due to that reason, wave making resistance was decreased by amount of 7% something. Next page. And then this is wave cut analysis. We measure all wave cut. So most of you can see, wave height was decreased for the optimized. Next page. Conclusion for this, 2 methods, similar results, good a little bit experimental results, but time, first why, parametric modification much effective. Actually, now I move to multiple optimization, okay, multi-object optimization technique using CFD code. This is optimization algorithm, all the method. This is gradient-based method. This is derivative-free, okay, multi-object method. So, as I, mentioned, SQT, one of these gradient-based method, good convergence computation efficient, this is advantage. This good advantage is local optimum. This is not conducting it for global. And single object, not multiple, multi-object. So there are so many, multi-object optimization technique. We use the P part to zoom optimization technique. So this predictive